Okay, so serverless security, securing your API gateway and Lambda functions. I am Jeremiah from Chicago, been in IT consulting, thank you, for 5 years. I like AWS, I like ice cream and long walks in the park, and wonderful conversations with my future partner. Just kidding, I'm married. Feel free to visit my website if you want. There's no promotion on there. It's just going to be a bunch of stuff that is going to be in this presentation and a little bit of bonus material after the talk is done. But I just want to start you guys off with something. So in 2023, a company's Lambda function was compromised because it had hard-coded AWS credentials with administrator access. The attacker pivoted from a single function to their entire account in under 10 minutes. Organizations move to serverless sometimes thinking that it's automatically more secure because AWS manages the infrastructure. But the attack surface doesn't go away, it just shifts. So how many of you are currently running a Lambda function in production? Can I see a show of hands? Awesome. Now, how many have documented security policies specifically for serverless? Oh, okay, that's fine, that's fine. Today, I want you guys to leave with a security checklist and the knowledge to lock down your serverless APIs without breaking functionality. AWS processes about trillions of requests per month. Serverless is no longer experimental. It's production-critical infrastructure that needs production-grade security. So let's go over the serverless security landscape. We have traditional versus serverless. We have the shared responsibility model in serverless. The serverless security triad. Why serverless security is different. Now, let's go over traditional versus serverless. And this is going to be a very high-level overview. In traditional, you patch the OS, you lock down the network, you monitor the servers, all that good stuff to get yourself up and running or your company up and running with a server. In serverless, there's no OS to patch. There's no network to configure, and there's no servers to monitor. However, you're still 100% responsible for application security, and that's a very important point, and we'll get to that in a little bit. So the shared responsibility model in serverless is that AWS will secure the physical infrastructure, the hypervisor, container runtime, OS patches, network infrastructure, all that good stuff, right? But you still have to secure some things, right? You still have to secure your code, your dependencies, IAM policies, secrets, the API access controls. But the thing is that the critical handoff point is that the IAM policies and functions configuration is where the most breaches occur. And let's see if we can fix that in a little bit. According to a 2023 report, 21% of organizations have experienced a serverless security incident, with misconfigurations being the #1 root cause. That leads me to the serverless security triad. Identity, who can invoke your functions? Data, how do you protect secrets and sensitive information? And code, what can your functions actually do once invoked? Now, here's why serverless security is different. We have ephemeral compute. The functions live for minutes or seconds, making traditional monitoring a little bit harder. Distributed by default. It's a simple API that might trigger 5 to 10 different Lambda functions, sometimes even more. It's also event-driven. Your function could be invoked by 20 different AWS services, each needing different permissions. No persistent state. You can't just log into the server to investigate. Now, let's go into the demo application and overview. I have the application, the AWS diagram, and the Terraform code. So, can everybody see this real easily or not? No? Okay. Let me see if I can increase it. Okay. Well, here you go. You have your security zones, observability, CloudWatch logs, your perimeter, your API gateway, which validates, throttles, and authenticates through and rejects malicious traffic and handles HTTP requests to the Lambda functions. All right? Now, the sanitation to prevent leakage is going to go into your CloudWatch logs. Your Lambda function will also log to CloudWatch. Your execution does go to CloudWatch. And they both interact with two different Lambda roles, a DynamoDB table, a secrets manager that does encryption and rest in transit, and that's about it. It's a simple demo, not too much going on, but it works. We're going to build a simple but realistic API for a user management system. We want host users to create a new user, and it stores it in DynamoDB. We want to get the user's ID, retrieve user information. This is going to require authentication via an API key. And it needs to call an external service using credentials from secrets managers, the secrets manager, excuse me. There we go. All right. So the API gateway. Usually it's a public-facing REST API that handles all HTTP requests. Lambda functions are, it's a business logic that processes the requests and talks to DynamoDB in this demo. The DynamoDB table is a data persistence layer. The secrets manager, it stores third-party API credentials. And the CloudWatch logs will capture all the logs, but will ensure no secrets leak here. And I'm using this because it represents about 80% of the real-world serverless APIs that I have seen personally. Of course, every use case is different, but this is what I chose to go with. So let's go over some of the parts of it. And this is where the meat and potatoes goes, so I'm going to go a little bit faster. Hope you guys don't mind. So let's look at the security layer 1. We're going to look at the perimeter, the execution, the data, the observability, and I'm giving you guys a full disclosure here. This is going to cost me about $0. If I let it run a little bit longer, probably about $5. Or if I have an overload of users, please don't use it up. My wife is already angry at me. I already went far beyond my AWS budget for the month. So use it with caution. So for security layer number 1, we're going to go over IAM roles and least privilege. Every Lambda function should have its own IAM role with only the permissions it absolutely needs. No more, no less. No real problem here. But there are some patterns to avoid. Don't attach the administrator access or even power user access to Lambda execution roles. Don't reuse the same IAM role across multiple functions with different purposes. And of course, do not grant permissions on resources unless there's truly no alternative to do so. When testing the IAM policy, we want to do these 3 things, right? So we only want to use the policy simulator before deploying to production. Intentionally try to do something your function shouldn't be able to do, like access a different DynamoDB table and verify that it fails. And enable CloudTrail to audit all API calls and review for unexpected permission denial. So here's a pro tip. Use the access analyzers to automatically identify overly permissive policies. It will flag things like resource and suggest tighter alternatives. The Lambda execution role versus resource policy. What can my Lambda function do? Who can invoke my Lambda function? So let's stop here for a little bit. How many of you guys have written your own Lambda functions? Cool. And how many of you guys have written a Lambda function that writes to DynamoDB using the policies that I outlined? Okay, pretty good. Okay, so we can speed up a little bit. So let's go over to a quick. I'm going to take you guys through the code. So let's do switch it to. All right. So I decided to set up my demo using Terraform. Some people still use CloudFormation. I went in a different direction. So in your main, pretty straightforward. We have the, there we go. Required version, required providers, data source, project environment. Now let's go and look at the Lambda. Okay, I have my dead letter queue. I have a zip archive of my Lambda code. The Lambda function, pretty short and sweet. Time out of 30, memory size 256. And we are looking at the environment variables here. Now what this does is that I will run Terraform apply, and it'll go through all these, it'll run through all these different Terraform files that I have here, create a state file, and go ahead and give me the outputs of variables and various Amazon resource names. Any questions here? No? Okay. You guys are a little quiet. If you have any questions, just raise your hand. It's okay. So let's go ahead and go back to, all right. Layer 2, security access controls, gateway access controls. Your API gateway is your first line of defense. Before any request reaches your Lambda function, API gateway can validate, throttle, authenticate, and reject malicious traffic. So, method 1. It's simple but limited, but it's API keys. Let's look at the internal APIs, the partner integrations, the low security scenarios. That is what API keys is great for. It'll include something similar to an XAPI key in request headers, and the limitations are that it's not really a security mechanism alone. You need to add some things, right? So when API keys are not enough, they can be long-lived credentials that can be leaked or stolen. They don't really identify individual users, just someone with the key. And they can't be easily rotated without breaking all clients. You want to use them for throttling and billing, but not necessarily for authentication. So, method 2, IAM authorization. It's best for service-to-service communication, SDK clients, high security environments. Requests must be signed with AWS credentials using signature version 4. And then there's method 3, Lambda authorizers. It's best for OAuth 2, JWT tokens, and custom authentication schemes. The API gateway will invoke a separate Lambda function to validate the token before calling your main function. And there's method 4. That's Cognito user pools. This is best for end-user authentication, mobile web apps with user sign-up and sign-in. And the API gateway validates JWT tokens issued by Cognito. So before I move on, we're just going to go over to look at what the demo is doing. You know what? Let's just move on. Here's the cardinal sin of serverless: hard coding secrets in your Lambda function code. My computer's a little bit slow today. Where secrets should never live: hard coded in your Lambda function code, in environment variables, in Lambda layers, in configuration files, in CloudWatch logs. Secret manager the right way is centralized storage for secrets, automatic rotation of secrets, encryption at rest using KMS, and fine-grained access control via the IAM. You only want to get secret value on specific secret ARNs. So, KMS encryption for secrets. The secrets manager uses AWS managed KMS keys by default. For compliance requirements, we want to use KMS, customer managed KMS keys. And we don't exactly want to, how do I put this? We want to do things in a execution roles, so KMS decrypt permission on the KMS key. And the benefit of that is the audit trail of every secret decryption in CloudTrail. So, at 4, we have dependency management and supply chain security. Now, these Lambda functions often pull in dozens of dependencies, each is a potential vulnerability. So we try to use pip audit or npm audit to scan for known CVEs before deployment. How many people know what a CVE is? Okay. So CVEs are good for checking out 0 days and new attacks or security events. If you go into your code and you use pip audit or npm audit in your terminal, you will see known CVEs, and in certain cases, they will give you an opportunity to fix them. So we want to pin specific versions in requirements.txt or package.json. We never want to use star or latest. We want to regularly update dependencies, right? Security patches, but test thoroughly first. Now let's move on to our Lambda layers. We have shared code, shared vulnerabilities. We have Lambdas, they're great for code reuse, but they're a vulnerable layer. It affects every function using it. We have to treat our layers as production dependencies. Version them, scan them, update them, do whatever it takes to make sure that they are safe. Don't put secrets in the layers, all right? They're visible to all functions using that layer. VPC configuration when necessary, all right? If you need to access these private resources, configure the VPC. By default, Lambda functions run in an AWS managed VPC with internet access. So you're going to want to set up your own personal VPC and then configure the internet access that way. The security benefit is that your function can't make arbitrary outbound internet requests. That is very important. The trade-off, though, is that the VPC Lambda functions have cold start delays and need NAT gateway for internet access, which is okay. We can set it up in Terraform very easily. So we only want to use VPC when we have a specific requirement, like accessing a private RDS or similar. Now, your Lambda environment variables are encrypted at rest by default. For sensitive configurations, we want to enable encryption headers. And we want to use KMS keys to encrypt specific environment variables. Now, they are still visible in the AWS console to anybody with Lambda read access. So we have to be careful about who we're sharing our console with and how we're granting our permissions. So in this layer, I wanted to set reserved concurrency to prevent runaway cost and resource exhaustion. We want to limit the function to 100 concurrent executions max. This prevents a malicious actor invoking your function 10,000 times per second and racking up a major bill. Fun fact, I actually did something similar about last year. And I had a public-facing website in S3. And somebody actually found the site and started just running it every 10 seconds. All it was doing was creating a URL link shortener. And you could send that link out to your friends and family, right? But for some reason, this guy kept running the same link over and over again to where my bill got up to about, I'd say about $750. So be very careful with concurrency limits. Also set per account limits to protect against runaway Lambda functions, Lambda invocations across all functions. All right? Now, the URLs versus API gateway. Lambda function URLs. They direct HTTPS endpoints for Lambda functions, no API gateway needed. Security consideration. Function URLs have less built-in protection features than API gateway. And you're only supposed to use them for internal tools, webhooks, very simple APIs. I mean, dead simple APIs. We're talking link shorteners, truncated code, stuff like that. When to use API gateway instead, maybe use a production API that needs throttling, validation, off caching. Let's go to code signing for Lambda. Let's ensure that only trusted code runs in your Lambda functions. Let's sign deployment packages with AWS Signer and the Lambda verify signature before execution. We only want to use this in high security environments, regulatory compliance, preventing unauthorized code deployment, simply because it can be very cumbersome to work through this stuff if you're doing it for a personal project or just for you and a couple of friends to just tinker around. Now, AWS depreciates old Lambda runtimes, right? So when they reach end of life for Python 3.7, Node.js 12, etc., they're going to remove it. Depreciated runtimes don't receive security patches. And we want to set up CloudWatch alarms for upcoming runtime depreciations. So let's see if it's available now. And if I can run. Let me see if the share works now. Go. Okay, so it's a simple sign-in, sign-up page. HTML, JavaScript. What's important here is that, see if we can look at the app.js code. What's important here is that I'm not storing things in clear text. I'm not hard coding the code in my JS file. I'm making sure that the script file is, see, this is why I don't like doing live demos. This is the exact reason why I don't like doing live demos. But I can take you to the code again, and we can go straight up into app.js. This is what we're looking at. So we have this. We are looking at the Cognito config, user pool ID, client ID, region. This is what I'm talking about. We don't want to store these things in hard code. This is only for demo purposes only. In certain cases, we'll be okay with the API URL in the code, certain cases. And then we have the DOM elements. Then we're going to load this API URL, save the configuration, and process our sign up, sanitize the inputs, validate the password. Okay, so check rate limiting, right? We want to make sure that there's not too many attempts. Give the user an error code. Treat the user like a 5-year-old, right? Give it guardrails. Don't let the child go too far into the deep end of the ocean. So we have our user pool, Cognito user pool, sign up, email, password, attribute list, and we want to store for confirmation. All that good stuff. Am I going too fast for anybody? Yes? No? No? Okay. Cool. Awesome. Any questions about this code? No? Okay. Well, moving right along. What we want to do now is go back to the presentation and wrap up the last 2 layers. Well, the last layer. All right. You can't secure what you can't see. Observability is security in serverless architectures. All right. We want to make sure that our CloudWatch logs are our security audit trail. All right. Every Lambda invocation is logged automatically. Your application logs also go here. Security events to log is authentication attempts, authentication failures, rate limit hits, invalid inputs. But not to log. Secrets, personally identifiable information. Unless you have a compliance framework requiring it, I don't believe SOC 2 Type 1 requires it, but I think SOC 2 Type 2 does require it. And you don't want to use it in HIPAA. Full request bodies with passwords, and we want structured logging for security. We want to use JSON format for logs. They're easier to query, easier to alert on. I think it's what most of us in this room are used to. Include context, so all the IDs, source IP, what action was taken. So we have a log right here that shows the event, the authentication failure. User ID is user123. The IP address, don't try to enter in the IP address. Please don't. And the timestamp here from 2024. This is actually one that I used for my URL shortener last year. So almost to the day, October 14th. So you want to have as much information as possible, but really only use what's necessary. So the query is, this is an example query, fields, timestamp, event, and so on. Now let's move on to the security layer of CloudWatch. I'm sorry? Yes. Sure. Yes. Encrypted should be okay. Oh, so the question was, we don't want to store clear text passwords, but is encrypted passwords okay? Generally, so it is okay, but be very careful with that. I have seen an example before with a client where they thought they were doing everything right, and there was still a leak somewhere in the back end. So just be careful with it and make sure that the rest of your architecture is locked down for that reason, if you're going to be storing those passwords. Oh, yeah. Anything else? Okay. So we want to set up CloudWatch alarms. CloudWatch is a very powerful Amazon resource that I like to use a lot. Maybe too much, but it will always send you a notification depending on your parameters, right? So a sudden spike in 403 errors, unusually high invocation count, throttling events. We want an alert if the failures exceed 105 minutes, right? If you're doing that, then it's possibly a brute force or credential stuffing attack. And we want an alert if Lambda function is invoked from an unexpected AWS region. I like to use email, but you can also set it up to have it sent to your Slack. Be forewarned, Slack, you can only do that with the premium version or the paid version of Slack. PagerDuty is actually really good. I've seen that in action before. It's really solid. So we want to record every API call made in the AWS account, right? And that's in CloudTrail. Who did what, when, from where. This is why if you go to a production environment, most likely you will see only access given on the CLI level. You don't want people going around and poking in the console for production level events or production in general, really. Security use cases, right? Detect unauthorized IAM changes, track who invoked which Lambda functions, and identify specific suspicious activity. So we want to enable CloudTrail for all regions, send logs to a dedicated S3 bucket, and enable log file integrity validation. And we want to use CloudTrail Insights to automatically detect unusual API activity. Now, let's go on to X-Ray. How many people have heard of X-Ray? Great. See the entire request path. API gateway to Lambda, to DynamoDB, to the secrets manager, to the external API. Right? There are some benefits with it, right? We can identify the unexpected service calls. Is there some drift in there? Is the function calling services as supposed to? And we can also find bottlenecks. So insufficient DynamoDB query, a slow API call, and we want to enable it with one line, tracing active, right? Now, here's guard duty. It's an AWS managed threat detection service. It analyzes CloudTrail, VPC logs, DNS logs from malicious activity. Compromised credentials, used unusual API calls, cryptocurrency mining, data exfiltration, all that good stuff. And it's only about $4 a month. So I kind of lied when I said that the demo only cost me $0. It's a little bit higher. So $4 a month for average account, and it's, in my opinion, it's well worth it for production environments. So let's look at Lambda Insights with CloudWatch. Enhanced monitoring for Lambda functions. Security angle, it detects resource exhaustion attacks. And it has a performance angle to it. It identifies over-provisioned functions, saving you money. So the incident response preparation is to document everything in the playbook. If we detect a compromised API key, what do we do? And usually when you're coming up with a playbook for this stuff, you want to have all the stakeholders in the room. Don't ever try to build a playbook by yourself. You might know everything, but there will be some blind spots that you have, some some biases that you might have about what you built, and you might not get everything or see everything. So what I like to do is that in my personal projects, I like to call upon a couple of friends that I know that actually know AWS, in some cases a lot better than me, and I'll just come together and see if I can create like a quick playbook or two for my own personal use. Rotate the secrets in Secret Manager. Revoke the API keys. Review CloudTrail logs. Check for data exfiltration. These are all sort of high-level things that you need to go in detail into with your playbook if you're running in production. And don't forget to run a tabletop exercise. What if an attacker gained access to our Lambda execution role? What is our response? How do we monitor this? How do we stop this? Mitigate the action. And if you're running a production that's SOC 2 Type 2, you're going to have these types of controls anyway. So you might as well write it down. So here's a couple of resources for you. The IAM Policy Simulator, the Access Analyzer, and the Trusted Advisor, right? And the Security Hub. Anybody heard of all these? Anybody not familiar with any of them? Any questions on them? No? Okay. Well, a lot of these are straightforward. Simulates the policy that you write for IAM, analyzes the access, Trusted Advisor. I think we all know what Trusted Advisor does. Security Hub. Third-party security tools. I like Snyk, Aqua Security, Twistlock, and Datadog. I would only use third-party security tools if I am using this in production. If I'm doing something on a personal project or a startup, I would be very careful because startups and personal use is going to be very cost sensitive. And all of these third-party tools, for the most part, do cost a lot of money. For me, at least. So there are some open source projects, serverless framework plugins, the IAM roles per function, Prune plugin, there's Prowler, Cloud Mapper, and Git Secrets. All of these are available on GitHub. Don't forget the well-architected framework, security pillar. It's a free white paper. Free resources is always good. Now the CVEs, the OWASP Serverless Top 10, right? OWASP runs those top 10. It gives you a top 10 list of things to look out for when you're building your serverless project, and security best practices for Lambda. And don't forget, this is not actually a free resource, it's actually a paid resource, but I love this book, Serverless Security by PureSec. It's great, you should check it out. So, security is not a checkbox. It's a continuous process that requires a lot of iterations and a lot of following up and monitoring. Serverless doesn't mean no security. It just means security in a different box. And your cloud provider handles infrastructure security, but you own the application security 100%. Now, I said I was going to help you guys out with serverless security. So here are 4 weeks to better serverless security, right? So we want to fix our IAM policies, we want to move secrets to the secrets manager, have those secrets rotate, add an API gateway authentication, and we want to set up monitoring and alarms. And if you do just focus on each objective for that week, you should be ready to go by the end of the month. All right? 80-20 rule. 80% of security improvements come from 20% of effort. So least privilege, no hard code, API gateway authentication, and you want to have CloudTrail enabled. Basic monitoring and alarms. Be sure to set your monitoring for your threat level and your comfort level as well. And these 5 things, it'll prevent 80% of serverless security incidents for 20% of the work. So, your homework if you want to take this seriously. Audit your existing Lambda functions. How many have overly permissive IAM roles? Search your code base for hard-coded secrets, right? Just do a little quick check. What's it gonna hurt? And finally, join the community. There's an entire track on serverless security for reInvent. Serverless Days has conferences in pretty much every major city. And then there's Reddit, I love Reddit, and the Security Hub newsletter. Thank you. Any questions? Yes.
I'm coming to you.
Yeah, I know I went through a lot, but otherwise you guys would look at me like, what the heck is this dude talking about?
So you mentioned X-ray, and I've heard people recommend using OpenTelemetry instead of X-ray because that's where AWS is going. And I'm just wondering if you have any thoughts on that, or if
Yes. Yes. You do want to do OpenTelemetry. I believe they're going to be retiring X-ray very soon. Don't quote me on like when that is, but OpenTelemetry, it works differently, but it still does the same things as X-ray with a little bit more functionality. Anything else? Okay, cool. Oh.
Wait.
My question is regarding this 30 projects in 30 days. What's about that?
Oh, that's just me challenging myself. I'm a weirdo, so don't just follow after what I'm doing. I'm just letting you guys know that, hey, November 1st, the slides will be up, the recording will be up, and I'm just going to take you guys through a bunch of projects that I've been tinkering with on my own. With videos, again, I don't even like doing live demos, even for tutorials. So you're going to have videos with it, a little bit of documentation, and a GitHub link. So, yeah.
My question probably is not related to your talk, but since you work for AWS, AWS is a big internet company that carries like 30% of worldwide internet traffic. So a few days ago, big outage worldwide.
Yeah.
So probably it's reported it's not a security issue, so it means no hacker was involved. But I think it's an issue, especially a technical issue. So after a few days, has anybody or have you found out real cause in its wake?
Yeah.
Frank, hold on. Hold on, Frank.
There's a very extensive RCA published by AWS. If you even do a Google search for it, you'll find it. But it's 12 pages long. It gives you time frames of exactly what happened. It's actually very interesting to read about. They pull the covers back quite extensively as far as how is network load balancers worked, how DynamoDB works, how they refresh it, how the enactor and the reactor, or whatever they're called, I forgot, but the implementer and the reactor, how they implement with each other, why they clashed, how that happened, why there was a bunch of empty records. It's very, very interesting, and it's a solid read. I highly suggest you go through that rather than have poor Jeremiah here go through that here.
Yeah, it's very, you took the words right out of my mouth, because it is a very deep dive into how things went so wrong. Full disclosure, I don't actually work for AWS. I work for myself. So yeah, that affected a couple of clients that I had, but all in all, on the I guess the business side or the client side, this is easier said than done, but I wouldn't have a single point of failure, which is very difficult because hyperscalers are very expensive, like AWS. And it's very expensive to try and have a backup or like eliminate that single point of failure. So unfortunately, a lot of the internet is going to be at the mercy of AWS, Azure, whatever cloud provider they have. Sorry, I wish I had better news about it, but yeah. The RCA goes into much better detail about what went wrong. But unfortunately, a lot of your providers that depend on AWS, They're going to have that single point of failure, and it's not going away anytime soon.
And it's always DNS
Yeah, always, always.
or a certificate.
It could be, yeah.
We do have NavNav waiting for us in the pre-function area. So
Wow.
keep asking questions, but we can't have food in here. So off to the other room. Thank you, everybody. Thank you, Jeremiah.
Thanks.